about the Mahaskala. Yeah, this looks like Luis. This actually didn't. It was more like, it sounds like Luis. Luis. I don't think so. Yeah. She's fine. Oh, good. You? Fine. Yeah, I just saw Diego, and he said that, yeah, I was talking to Luis, and then, oh, is Luis here? He said yes. Yeah.
I think it's 2 o'clock. 9 a.m. So that is how we can get started, right? Are you able to share the slides for this one? Yeah, cool.
I shared my screen.
Yeah, thank you so much. Maybe another minute we can get started. Yeah. So Eric, we can get started. Not sure who's in the room. So when did you reach Vienna, Eric?
I'm sorry, say that again?
No, yes. When did you reach Vienna?
Oh, I did. I'm still in California.
Oh, you're still here. Oh, okay. I didn't see you. Yes, I'm sorry about that. Yeah.
It is 2 a.m.
Yeah, incredible.
Who doesn't, by the way? Okay,
Yeah,
see some
there is
people.
some. There is echo from your side, Sakura-san. Not sure. Okay, maybe should we get started? Okay, all right. Uh, Thank you everyone for joining this DMM working group, IETF 113. So myself, Sri Gundavelli from Cisco, and my co-chair, Sakura-san, and our area director, Eric Klein, online. We are attending this meeting remotely. Next slide, please. So the first thing, the IPR statement. By attending this meeting, you're agreeing to comply to the IETF rules and policies. If you disagree, please leave the meeting. And the IETF rules and are documented in the following RFC specifications. Next slide, please. This is a notable statement. Please read this and next slide, please. So first thing, blue sheets. Eric, how do we coordinate this? Any ideas?
The meetup will automatically record everyone who dials in. Are there blue sheets in the room? If not, there's a mobile app. There's like the MeetEcho Lite you can use that can record your participation as well.
Okay. So are we supposed to do anything, or it is automatic? It will take care of
If there's no Bluetooth in the room, then probably I would request everyone to sign into the Meet Echo Lite. That way they can join the queue and observe the chat.
Okay.
Can
I think we
anyone
must be
hear?
provided Bluetooths.
I don't know.
All right. Any note takers? Anybody, please? Pablo, you're welcome. You've been our note, default note taker for the last few meetings. Do you mind taking some notes, Pablo?
It was fun.
Yeah, sure.
Thank you so much once again. All right. Next slide, please. This is the agenda for our meeting today. First thing, a quick update. These are the three IETF, the working group documents. One is the segment routing IPv6 mobile user plane, then the mobility aware transport network slicing for 5G, and the user plane protocol and architecture analysis for 3G, 5G systems. These are the documents. These are the documents, working documents. The last two, next slide, please. There have been recent updates to the following two documents. Next slide, please. And the last one, there was no update. So today we are going to hear the presentations on these two topics. And then next slide. A few other topics. Yeah. Next slide. Yeah, these are the individual documents and a couple of new presentations today. So first we'll get started with the SRv6 for mobile user plane. Pablo, are you going to do the update today?
Yes.
Okay. So can you, Dr. Kasan, if you can share the SRv6 slides.
So let me try.
So I think just to remind everyone, this document went to a last call sometime last year, but there have been few comments and concerns. So that's why we did not, we asked the authors and the folks who provided the comments to resolve the issues. So there have been, some progress, and I thought it's now pretty much, we are almost ready to move to the next stage, but we'll confirm that after this post IETF meeting. So I want to give the opportunity to the folks who provided those comments to review and make sure the changes that are in the document resolves their comments. And so but let's hear from Pablo's what the changes were and exactly what the authors believe with respect to the status. Pablo, it's all yours.
Okay, thank you, Sri. So good morning or good afternoon, and many thanks for your time. So this is an update on SRv6 mobile user plane. So briefly to recap a bit on the state. So we started the working group last call in April last year on revision 11. We had a good amount of participation with many comments, and I really appreciate the comments of everyone to have improved the document. And well, throughout the last IETF 112, there were a number of issues that were still pending, and we believe that they have been solved. Next slide, please, Atrusan. Okay, so one of the comments that was outstanding, it was the comment from Joe Halpern related to sections 5.1, 5.2, and 5.3, where basically we are, well, the document is defining, or well, yeah, it is defining how to you could use the SRv6 endpoint behaviors, which are defined in the document, to build an SRv6 mobile user plane. The view or the comment from Joel, it was that these sections are not a standard. And the discussion that we had around them is that this text is providing value to any operator who is deploying this technology. So we did not want to remove the text. And so basically the solution that we found was to add one small paragraph at the beginning, just mentioning that these three sections are merely informative. So we have added one paragraph about it. I believe Joel is not, I don't know if Joel is here, but anyway, please review the paragraph, and if there is any, if you want to change the specific wording, we will change it, but for the rest, it should be good. And then the other pending comment that we had, it was a few email exchange with Jeffrey. And from this email exchange with Jeffrey, there were a few editorial things to change in the pseudocode, and it has been changed. Basically. Next slide, Satoru. So given that this draft has been, well, the working group last call started in April last year, and given the vast amount of changes that we have done on the draft, the authors believe that it would be good to issue a second working group last call. I don't know what is the view of the working group chairs. And that's really it. Many thanks. Sorry, I do not hear you, but I hear your mouth moving.
Thank you, Pablo.
Thanks. Now,
Thank you for your presentation. So there have been few other comments. I think I thought yeah, I've discussed with you and other authors. So overall, with respect to, we also wanted to make sure, from 3GPP point of view, when we say this is the interfaces that we refer to, right? It does not alter the definition of the 3GPP, right? So we wanted some convention, some wordings, which says that this is IETF, the version of the interface, right? That way, it's not truly, we are not altering the 3GPP specification. That has been one comment. Any any comments, Pablo, as exactly how you have resolved that comment? Can you share a bit more details?
yes, sure. So basically, at the beginning of the draft, I believe, I don't recall if it's section 2 or 3, we have paid particular attention to the wording. And so basically what we said is that we are going to use as reference architecture the 3GPP reference architecture for 5G with the corresponding interfaces references. However, it is also specified in the text that the mechanisms that are defined in this document could be applicable to any other mobile architecture. And so basically throughout the draft, we have been paying attention to the wording and to make sure that this is generic enough.
Okay.
So that's a bit how we solved it.
Okay. All right. I think we can review the text and we can take it from there. But largely, the issues that I'm tracking. So I think hopefully is addresses all those comments. I think the next thing post IETF, probably sometime next week, I'm going to issue a second last call and to make sure Joel and others, right, who have been quite active and who have provided substantial feedback to review the changes and acknowledge that they're okay with it. I think that's a plan. And so thanks again. At this time, any questions from anybody from the room or from remote for this? Anything that you'd like to comment? Please raise your yeah. Is anybody on the queue? I don't see anyone in the queue. All right. Okay. If not, thanks again. We move to the next topic. John.
We can't hear you in the room if
Ah,
anyone's talking.
Thank you.
so assuming no questions from the room, we go to the next topic. Is there a question? I see somebody at the mic. I'm not sure. If there is no question, is there a question? No. All right, John. John is, yeah, you can let me.
Thanks, Shay. Can you all hear me?
Slightly your audio is coming out a bit low. If you can speak out a little louder or closer
Okay.
to the microphone,
Okay.
please.
Is this better?
Marginally, slightly. Yeah.
Marginally. I'm sorry. I don't know. Maybe I'll speak a bit as loud as I can.
Okay. Yeah, this is better.
Oh,
Better. Better.
it's better? Okay.
Yeah.
So this is the mobility-aware transport network slicing for 5G. I don't
You're
have
sharing.
slides.
1 second. 1 second, John. Sir. Satoru-san, are you going to share the slides or the sharing?
I don't have slides, Shay, or Satoru-san. Uh, it's a simple update that I can talk through, to give what the changes were in 03 version.
Okay. All right.
Um, okay. So there were the main comment from the last meeting and discussions were that the draft text is all over the place and that it needs to focus. So and then there were some other comments too, which there were a couple of others reference to drafts on slices, and then there's a few miscellaneous changes too. So focusing on that first one, to correct the fact that the text is all over the place, we revised significant portions of the introduction. And there are two main changes which I'll just talk through. Basically, it's that a slice, I mean, we say what a slice is in 3GPP, that it is a logical chunk of 3GPP network resources and how they're created and all of that. The text is in the introduction section.
I
And
think we're going
then
to
we
have some
also,
testing time because we can't hear. Well, you keep cutting in and out. Does it make sense to stop and have a test or something?
Yeah, John, I think I'm not
it's
sure
hard
how
to
we.
hear. I wonder if one of my colleagues is there, or I can try to share my screen, but if that's okay.
Please.
Can you give me permission?
Just, yeah, you have it.
I hope you can see my screen.
Not yet. Yes, yes.
Okay.
John is trying to share the screen. Wait just 1 second.
Can you see the screen now?
Okay, hi, can you hear us from the room?
Yes,
I
please.
can hear you.
Yeah, but we cannot hear you. You're cutting in and out.
I'm not sure what I can do about it.
All right, John, anybody else
Is it better?
who can do the presentation?
Audio is from your side is horrible. John, there's no way
Yeah.
we can hear you anything.
Okay. Then I guess I'll post these to the mailing list, the changes that we've made.
Okay. So, John, we'll try again. We'll move to the next topic and see if something,
Okay. Okay, great.
in the meanwhile, we'll be able to resolve this, right? Okay.
Okay.
So, Sato-san, next.
Can folks in the room confirm whether the issue was just with John's audio or with all remote audio?
So we can hear Eric, Shri, we could hear, and then he's gone, and we could not hear John at all.
Understood. Thank you.
So the next presentation is mobile user plane message encoding. This is an individual ID. Murakami-san is going to, Murakami-san is going to do the
Can I
presentation.
hear you?
Yeah, we can hear you.
Okay, so good morning. So this is the mobile user friendly message encoding, 05 version. So please go here. Yeah. So here is change from here to feature one. So we define almost up message to carry the secret number for GDP message, and also add the cheap flavor consideration section in order to discuss about the PFP and the USB base. Please go to the next slide. This is the change from tier 01 to tier 2 version. So instead of the IETF draft, we are installing RFC HC7 54. Please go to the next slide. Yeah, this is the change from Tails to TLC. So we added security consideration into this part. Yeah, please go. Yeah. This is the change from the 03 to 04 and also 04 to 05 latest version. So we are just fixing the some title in the draft. Yeah. So here is the next step. So we are thinking. So document has been already very stable. We have already collected all titles. And also, we are thinking to call the double draft adaptation. Yeah. Any comment? Yeah. So let's see. Suppose
Okay. Thank you, Murakami-san. So yeah, this document has been in existing discussions for a while. I think we'd like to definitely issue a adoption call, but before that, we just want to make sure people have read and wanted to see their views. Probably, yeah, Dean has joined the call. Yeah, Dean, your question.
Actually, I have a question. We cannot hear anything in the room what is being presented. So Shri, you're coming in and out, but the presenters, we cannot hear them anything. So whatever is being presented, we don't know what is being talked about.
Oh, is it? Okay. I'm not sure.
So
if this
Shri,
is the
yeah,
thing.
Shri, can you hear the presenters? Yeah, we
Yes,
cannot.
I can barely hear. It's not coming out clearly. I agree. Yes.
So we have then the same problem.
Okay. I understand.
And in the room, it's much harder for us to follow because of the audio. We cannot put like a headset and then trying to focus on that one.
Right. No, I understand. Yeah.
So I try to find someone in the NOC on Slack to see if they can come diagnose what's going on. But I don't know if they're going to get there.
Yeah, I got. See, Eric, I'm not able to figure out whether it's the tool problem or is it, the individual session issue. I think that's not clear.
Seems everyone can hear you, Sri, so maybe
We
you
can
should
hear
present.
Sri, we can hear Eric, we can't hear anybody else.
That's strange.
This is John. I tried to reconnect. Can you hear me better this time?
I can hear you, John, but the room has to.
John, that was better. I think we can probably hear that. Yeah, we could hear you that time, John.
Oh,
Okay.
that's interesting. I just switched my browsers,
It's a browser issue. Okay. So, Murakami-san, you want to try switching the browser as well?
I will try.
Okay, actually, now it's much better. Eric, yeah, interesting. It's much better. So sorry again. Someone in the room can confirm if Murakami-san is okay, coming out okay now. Sorry. Yeah.
Can you please share what is the browser version that you're using so that we know what to recommend?
So I switched to Chrome from the Windows browser. So that is it.
Okay, John is using Chrome. Okay. All right. Murakami-san, just speak out one more time. Just see.
Yeah, so I'm using the Safari. So,
No, it's all right. I think let me give an update on this. So this document went through several revisions. There have been some discussions. I think we'd like to issue an adoption call. Probably, I think I'll poll the working group over email. And now it's difficult for me to track, as who read the document or not. So I'm going to do it online. The chairs are going to issue an adoption call on this. So, but if there are any comments from the room or from remote participants, please speak up. The queue is open now. All right, since there's no presentation, nobody has the questions. So we'll move to the next topic. Satoru-san again.
Okay, let me share.
Yeah. There's a. Yeah,
Can you
please
see
go
the
ahead.
slide? Okay.
Yes.
So this is the update for SRB mobile user playing architecture for DMM draft. This is a very brief update here. We made the two revisions from the last IETF meeting. We have a 03 version now. The main update from 03 version was simplified for the architecture, what the protocol using, what the architecture description looks like. To first update, we dropped SRPC requirement. Actually, 01 version has some idea to utilize the SR policy, but some of discussion we made, we understand that the SR policy doesn't need to be involved in the architecture, so we drop the SR policy. Then binding 6 as a next step for session plus form route, not be necessary. The second update, the architecture description. We have a bunch of the text updates, but fundamental architecture doesn't change. So the main change for architecture description was focused on the segments instead of the role of the node. That helps architecture description much simpler. The second point of the update was clarification. We made the MEP segment, the interwork and direct segment, be clarified. And also the TE can accommodate both interwork and direct segment. or simultaneously. The other thing is routing information. So we clarified the two discovery routes for interwork and direct segment, and the session transform route. We briefly described what the session transfer route look like in the 01 version. Well, now 03 version have clear text for type 1 and type 2 session transform route. And in addition to that, we require some idea using extended community to indicate the direct segment. That's also clarified. And also, the last thing, we have protocol draft uh, in a separate document. The document specifies the new circuit to put the session transfer information to BGP. That's all of the update we made from the previous version. That's all. Thank you. Any questions? Oh, next step. Maybe we have some more clarification in next revision, and also if we needed more use case or some helpful illustration for better understanding, then we may request working on that. Thank you.
Okay. Thank you, Sakura-san. So this document is again an individual ID. As
Yes.
Sakura-san is saying, we need to issue uh, we need to issue an adoption call at some point. So we'd like to see more discussions on the in the mailer. There haven't been many on this topic. So I think maybe I think Sakura-san and other authors, we may want to trigger some discussions to that will help us set the ground for the issuing an option call.
Yep.
So I think, yeah.
Any discussion are really welcome in the mail.
Okay. Thank you so much. And any questions from any questions from the folks in the room? Okay. If not, anybody, any remote participant, anyone has any questions? I don't see.
I raise my hand. Hello?
Yes. You have a question on the previous document?
No, yes, exactly. Well, actually, I raised my hand and tried to ask question since you did not see my hand. So,
Okay.
uh,
PNG, yeah, please go ahead. Yeah.
yeah, I have some question here. The things like I only have a lot of echoes here. By the way, um, I only read through the version 01. Now it's 03, and then it seems because when I read through the 01, I got a question on the MUP, the controller itself. Instead of about basically it focus my question focus on the interaction between the IP of the transport domain and the 5G MUP plan. Here is the 03. Seems you add more message types or you try to handle all the signaling things. My question actually is for your MUP, the controller. Um, how are you going to, basically for the 5GS system, the architecture itself? Um, I really want to know how are you going to put your the MUP controller? Are you going to consider as a NF network function, or you consider as a application functions or AF?
or something else because it's going to introduce some complexity for the 5G as a control plane. So basically, my question might not be related to this zero 03 itself. Basically, it's related to how are you going to integrate the MUP, the controller, all the things with the 5G as functions.
Thank you very much. Your question. This is Satoru. I'm not trying to answer your question. As we described in our draft, SLB's map architecture is independent from any specific mobility management architecture, not only for the 5G but also the IETF architecture, PMX, for example. Integrating SLB's map into specific mobile SAT architecture is out of the scope of this document. Map controller just provide the API to receive the system information from outside of the database map. So maybe someone wants to integrate database map into existing or future mobility architecture. So it may make someone uh, define or implement some idea to integrate the database map at that time. So far, it is out of scope of this document in terms of the architecture.
Okay. Now it's clear to me since when I read through the zero one, I always had this question. Now I understand.
Okay.
So that is, yeah, okay, orthogonal from your proposal right now. So, okay, thank you.
Yeah. So we described the 5G as an example for the ease of the understanding of the architecture. Maybe it is possible.
Okay.
Yeah.
Yeah, the things like for the operator, this type of things it's not very trivial to introduce. So that's why I have this question in my mind. So
Yep, yep. Thank you very much.
thank you.
Thank you, Tianji. Anyone, any other questions? I see nobody, uh, either the microphone or in the queue. All right, we move on to the next topic, please. Next one is mobile user plane evolution. This is a new document from Jeffrey and folks. Jeffrey,
Yes, can you hear me?
yes, clearly.
Okay, I'm speaking with my mask on. How, does that affect the audio?
So far, it's coming out okay.
Okay. How much time do we lose? Did we lose a lot of time? Because if we did, then I may skip some slides.
It's fine. I think
It's fine.
we should
Okay.
we should be able to. Yeah.
Okay, thank you. So I'm going to talk about two drafts here with courses Kier and Chenji. Next slide, please. So the purposes of the first draft is to give overview on the 5G user plane and talk about the trend of distribution and alternative implementation. This is to set the stage for the discussion in the next draft. So the next draft is about potentially in the next generation, as for example 6G, to integrate the GNOB and UPF function together. Some thoughts I have exchanged with some other people, my co-authors. We want to socialize this idea first. The work would have to be done in 3GPP. We're not trying to do the 3GPP work in IETF. But we want to socialize idea first among the people who are familiar with and friendly with IETF wireline technologies. If we get enough support, then we would bring to 3GPP there. So that's the intention here. Thank you. Next slide. So this is a picture of the 5G user plane. On the left side, we have the UE, and then next to it, the Geno B, and maybe intermediate UPF, and finally anchoring UPF. So from the UE to the Geno B is the radio layer protocols, and then from the Geno B to UPF, we use GTPU. There is relay going on between the radio layer, radio protocol layers, and GTPU, and the relay going on in the intermediate UPF, and finally it reaches the anchoring UPF. We decap the GTPU tunnel, we do the routing switching, and then send the traffic to the DN. Here, by routing and switching, I mean that the traffic forwarding is based on the IP header or Ethernet header of the that is below the GTPU header. Next slide, please. So with edge computing, nowadays UPFs are being distributed closer to the Geno beats, and as a result, the data networks are also distributed to those sites to host edge resources. And that means that the data networks are implemented as a VPN, as VPNs for intersite connections. While the central UPFs can remain, they could actually be removed. And with distributed UPFs, the persistent IP addresses can be provided even if the UE is re-anchored from one UPF to another. This is done by host routes in the data network VPNs. It's just like a MAC address routes for the Ethernet case. This allows complete local breakouts of the traffic to local data networks that are interconnected, and this simplifies and also optimizes the edge computing, broadcast service, and LAN type services. So you can see that in the picture. We have on the right side, we have the transport network. It provides VPN services on PE1, PE2. We have VRFs, VRF1 and VRF2 for local data networks, respectively. And then there is a VPE3. Also has corresponding VPNs, VRFs for the central data network, which could be internet itself. Nothing really changes except that the UPFs are distributed. Next slide, please. So there also at least in this DMM working group, we have been talking about alternatives to UPF and the GDPU implementation. Some operators and vendors are actually pushing for this alternative implementation deployments. This is under the hood. No 3GPP architectural signal changes are done. One example is the SRv6 replacing GDP tunnel that the draft, the Pablo was talking about. And the other one is SRv6 map architecture that Satoru just talked about, which is SRv6 specific. It's really just a router-based and partial implementation of the distributed UP. That's how I see it. Next slide, please. In particular, for the SRv6 map architecture, and this actually sort of answers the question from TNG. At least the way I see it, the collection of distributed map controller, map gateway, and map PE appears as a single and central UPF to the SMF. That's it. Nothing else changes. It is an alternative to the distributed traditional UPF. Another observation I want to make here is that the SRv6 map architecture or solution is actually SR agnostic. It can be it can work with MPLS with or without SR. In fact, for the BGP signaling draft that goes together with the SRv6 map architecture, there is another version that is SR agnostic based on that existing draft with minimum changes. I want to point out this is so far just for partial UPF functions. If someone wants needs a complete set of UPF functions, then either that architecture can be extended or just deploy traditional but distributed UPFs. Again, this is just the overview and summarize all the 5G user plane options and then trends, things like that. Next slide, please. Now, finally, I'm getting to the second drafts I mentioned earlier. What if in the next generation, for example, in 6G, we completely integrate the GNOB and the UPF function together? Yeah. This is not for 5G at all. It's a potential for 6G. If we can get enough support, then we can bring it to 3GPP. Here, basically, the GNOB and UPF are integrated into a single logical entity. The PDU session terminates at the integrated function, and routing switching happens right there. This is the picture that you can see that it's simplified from the previous pictures. What happens here is basically the 3GPP/wireless technologies are used to connect UE to that new integrated NAP entity. And then from there on, it's just IETF/wireline technologies. Next slide, please. So a big question is, why bother? The main reason for doing this is that this is a simplified flattened network architecture with 3GPP and technology for radio access and IETF technology for the rest. It allows seamless integration of wireline and wireless services. And I'm not talking about WWC. It's really for that edge computing, multicast broadcast service, and NAND type services. All those things we can do seamless integration between the wireline and wireless services. Besides, when we integrate those two entities together, we can, both the signaling and data plane can be optimized. Currently, we need a separate N2, N4 signaling to the GNOB and to the UPF. And there is a need for the GGBU tunneling between the two devices. When we combine them together, we do not need a separate N2, N4 signaling. And we do not need that separate connection between the A and UPF. No matter how close they are, if the two entities are logically separate, there will be a connection between them. It could be internal connection. Also, because now the network functions are more and more virtualized, this is actually very feasible to do it on the servers that host those services currently. In fact, even the VPN-PEs could be integrated into that NAP devices. That's as an implementation choice. Next slide, please. I do want to point out there are still cases where separate UPFs may still be needed. For example, home routed roaming, MVNO, or just sometimes you need a UPF to connect for multiple GNOBs in proximity. When there is that need, The AN-UPF connection can be the GPU tunnels, or it could be IETF pseudowires. Everything is possible. This is just that when you do need to separate them, it can still work. But when you can integrate them will have advantages. Next slide, please. So these two drafts are both informational. The first one just to give the background and set the stage for the discussion in the second draft that talks about the potential integration. And again, the purpose of this is to socialize the thoughts. I want to get your comments, and if you're sympathetic to this idea, let's talk and let's collaborate. And if this makes sense, if we get enough support, then we can bring this to 3GPP.
Okay, thank you. Okay, thank you for your presentation. So I think a few questions before I open up the mic, right? I think I do want to say a few things. This working group, we truly don't have the complete charter to go change 3GPP architecture. We are generally open to taking up work that allows us to use IETF tools and improve the system, but it's not exactly, we are not chartered to change the 3GPP interfaces, right? With that, keeping that comment in mind, I think, I think you talked about a number of things, right? Collocation of GNB and UPF and a few other points, right? I think, can you comment on like what exactly the changes that you're suggesting, right? Are these changes, fundamentally to alter the 3GPP system, or is it about using IETF tools to improve the system? And any comments, anything on that aspect?
So today, in the centralized UPF, the GPU tunnels are used to bring the sessions from Geno B to the central UPF. And in the distributed case, especially in the SRv6 map architecture, we are sort of breaking the central UPF into distributed ones. But still, there's still a separation between the Geno B and UPF. So if we could convince that 3GPP that we can actually integrate the Geno B and the UPF, then yes, the IETF technology will be used to connect those all those integrated devices together at the data network level. The PDU sessions terminates at the NUP, and then from their point on, it's IETF technologies. It's very much like you connect your PC to a router using Ethernet, and then the rest is just wireline networks, right? Here you replace the Ethernet cable with the radio access, and the rest will be the same as the rest will be just wireline technologies.
Okay. So do you see any relevance of this work to the IETF mobility architectures? If you look at over the years, we have standardized many protocols. You have the IETF mobility architectures based on mobile IP, basics, PMIC basics, right? Any comments on applicability of this to that architecture?
So I mentioned that I'm here basically a socialist this idea. I don't expect the work to be done in this working group.
Okay, got it. Okay. Thank you so much. Yeah, I think let's open up the queue. Any comments, questions, anybody? Yeah. Yes. First, let's start with Zoe. Yeah.
Oh, actually, the first
Wait,
one
sorry.
is myself.
Yeah, yeah, sorry.
I'm Jeffrey. Yeah.
I know. Sorry. I know. I mixed up names. Hanu is on. Hanu is next. Yeah. I know you can speak up. Yeah.
Everybody use Google products.
Okay,
Hello.
you
Yeah.
can hear
Yes.
me now.
Yes.
Yeah, good.
Yes.
Okay, thank you for a interesting, thought-provoking presentation. I have a couple of comments to it. First, I'm comparing the proposal to what exists in 5G, not 6G, because it's still pretty much under works. So first of all, in 5G, it's already possible to co-locate intermittent UPF, IUPF with the access node or G node B. That's already a possibility. Therefore, it seems that bit of redundant to go to that direction. Uh, but then, of course, this intermittent UPF assumes that there would be this PSA. Uh, but if you and your proposal is moving PSA to the access node. But if you do that, I'm wondering how would you handle then multi-access scenarios, for instance, interworking uh, with non-3GPP interfaces. This is not clear to me. Secondly, it seems that this is impacting 5G quality of service model, and related to that is that you could, of course, imagine to build this 5G quality of service model into the G node B. But if you do that, then you enter up into security problems in comparison what exists today, namely that now access nodes will know the subscriptions and the user IDs, which typically are hidden from the access network because we have this notion of access network sharing. These are my comments.
Thank you, Hannah. Jeffrey. Yeah.
So the first one, the co-locating of GNOB and UPF function. Yes, you can do that today. But even with co-located functions, you still need separate N2 and N4 signaling, and you still need that a connection between them. And so by actually combining them, integrate them together into a single entity, you would simply optimize both the signaling and data plane. That's the reason we want to have this option. About the security of having the subscription information available on GLOB, the impact of security, I indeed have not considered that carefully. I will look into that further.
Okay, how about the multi-access support? Can you comment that?
Multi-access, you mean the non-3GPP access?
Yes, yeah.
I would think that it is the same. To me, the only difference is whether it comes in on a radio link or on some other methods. The idea is that however they come in, and today, where you today just relay it to a GPU tunnel, you will just terminate it right there and go into routing and switching. So it should not matter whether it's a 3GP or non-3GPP access.
Okay, thank you. Let's continue on the mailing list.
Yeah, I think this is a good topic. I think yeah, let's take these discussions to the mailing list. I think Hanu had some great comments on non-GPP access and other things. Overall, yeah, I think let's see the relevance of this work to this DMM working group. Any other questions, Dean?
Yeah,
Um,
there is a queue. John wants to
Yeah,
put in, and myself.
Hi, Sri,
yeah, Dean. I think John, you have a question here?
yes, I had a few comments, but I
Yeah,
don't
please
know.
go ahead. Yeah, please go ahead.
Okay, thanks. Somewhat similar observations as Hanu, but the focus I thought in the draft was to emphasize on the routing aspects of these UPF and AN, but I was wondering about things like, for example, QoS and the aspects defined in 5G. So, for example, even in release 18, they're going to work on further extending QoS in XRM and others. But even the standard 5G QoS aspects need to be considered. So that's one aspect. And then the other one is about access control and permissions, especially when you come to things like network sharing. So, you know, if there are multiple operators sharing resources, then those aspects have also got to be considered. And I think that third aspect may be if mobility management is impacted. And perhaps it's simpler, but it's need to be discussed in the draft. I can post maybe a little more detailed comments in the interest of time and on the mailing list.
Okay. Yeah, that's a
Thanks.
good idea, John. Thank you for your comments. I think, John, if you can open up, this on a mailer, I think that will be great. Yeah.
I'll be happy.
We'll, clock the queue here. I think Dean next, and after that, Luis. Yeah, Dean.
So I really like the draft, and I want to support it because what Jeff is bringing out here is the simplifying the routing in the 5G user plane. He's not changing any parts of the UPF control plane. He's not changing any one of the uh, mobility signaling interfaces. He just wants to terminate the data plane packets as close as possible to the wireline, when it enters the wireline architecture, and then put it out there as a IP packet. The previous examples are trying to replace one tunneling technology with another tunneling technology, and I don't see that as a progress. We are just replacing this one thing with the other thing, and we are staying with the same mechanism. This is differentiating that once it hits a wire line, we're not continuing on the 3GPP architecture. We can continue with the pure IP architecture that we can then decide what do we want. On the QoS part, the data plane QoS, we know how to handle that. On the security part, we also know how to handle, the data plane security. Yes, there are some issues that could be between the user plane that stays in the control plane that stays within the 3GPP part. But if you apply a pure CUPS architecture where you have one controller with multiple user plane elements, this is exactly what Jeff is proposing. He's saying, like, we will continue to have the UPF control plane centralized. We will just have multiple data planes that will be exit points with the pure IP traffic. So from all the proposals, this is the one that I see that is most simplified and enables us to do routing, and this also helps with the mobility aspects for the DetNet, for the DetNet working group.
Okay. Thank you, Dean. Next, we'll go to the next comment. Luis is next in the queue. Yeah.
Yeah, thank you. So probably another scenario to look at, somehow seeing the same problem from a different angle, would be in the case of the radio functional split, where we centralize some part of the radio, the baseband unit, and so, which is naturally being centralized. So probably collocating also with the CU, the UPF, could be advantageous. So it's another way of looking at the problem, I think.
Okay. Thank you, Luis. I think key thing is we want to make sure, we are not saying, we change the 3GP architecture here. Let's understand it. If it's more on the routing side, on the N6 side, I don't know what are the implications, but we need careful analysis, and then based on this, if it's relevant, we can take it up. Yeah. Hanu, I close the mic, but you can quickly, if it's a quick comment, please respond. Yeah, I'll allow you. Yeah.
Okay, so this is not changing the UPF architecture. This is just applying the CUPS for the UPF, and that is legal by the 3GPP. That is supported by, you can apply CUPS to UPF. So this proposal is completely within the 3GPP, framework, given framework, the current architecture.
Okay. All right. Thank you, Luis. Yeah. Anu? Yeah.
Yes, comment back to Dean. This looks simple because you haven't yet hit the difficult part. For instance, this uh, multicast demonstrates very well the difficulty if you push the multicast server next to the access and you make a handover. You are you are making the handover signaling more complicated. Same happens in other scenarios as well. We need to have this TSA anchor higher up in the hierarchy in order to preserve the existing mobility signaling.
Well,
Yeah.
so multicast is
No, Luis, I think
okay.
let's,
We can take this offline.
yeah, well, I think I just want to make sure
I
I don't know how
disagree
much
with you on
time we
that,
have, but
Yama.
because we have to repeat some few presentations, we'll see if that happens. Yeah. So thank you, everybody. I think there's some good level of interest for this. I think we'll do this in the mailing list. Yeah. Next topic is we move to the next presentation. Again, thank you presenters for the previous topic and all the feedback. Next one is 5G distributed UPS for the 5G multicast and broadcast services. This is a new document, zero version from TNG. TNG, it's all yours.
Yes. Can you hear me right now?
Yes.
We good? Good.
Yeah.
Okay. Oh yeah. Okay. Thank you. Good day, everyone. My topic on this one is regarding the distributed UPF. When it's applied to 5G multicast and broadcast services. And also thank you for Jeff. So basically, he has already presented about the DUPF. So it's going to save me a lot of time on that part. Next slide, please. Three. Next, please. Yeah. For this slide, it's about the uh, introduction or it's the description of the DUPF in 5G user plan. So it's all the details are in the draft. Jeff and Q and myself composed. So I'm not going to repeat things that Jeff has already gave a very good presentation. So the next one, three, the next slide.
Yeah.
Okay. Oh, it's all gobbled.
Yeah. But I think maybe the format. Yeah, just speak to the slide. It's fine.
Okay, oh,
TNG.
yes. Let me. Okay, so here, but actually, I need to read something here. So, but okay. So this picture is regarding the 5G MBS architecture, and then I just put some simple brief things here without giving the full details. Not sure you can see the some interfaces. It's like N6 and B toward the right between.
Uh, Satoru-san, we lost the sharing.
Yes, I think
One
my
second.
slide is okay.
Yeah, yeah, just
Just
one second. Satoru-san? Yeah. Yes. Yeah, this is good.
okay.
Please
Now
go ahead.
it's good, but it's okay. How can I enlarge? Oh, okay. Now good. Thank you.
Cool. Thank you.
Yeah.
Very good. Yeah.
Okay. Well, it's much better right now. So here, I just describe briefly about the 5G MBS based on the 3GP document 23.247. Here, you may pay attention to three interfaces on the data plane. One is the N6MB between is toward the right side between MBUPF and the DN. The other two are N19MB between the UPF and BUPF, and then the other one is N3MB between MBUPF and the G node B. Here, for 5G MBS, there are two delivery modes. One is the individual, the other one is the shared. So for both cases, so when the downlink MBS packet from MB UPF where N6 MB, the MB UPF is going to replicate and forward. And then based on the either individual or individual delivery or the shared delivery. So according to the 3GPP document 23.247, from the MB UPF or either on the N6 side or N19 or N3 side, either the unicast underlay transport or multicast uh, underlay transport can be applied. So basically, you're going to deal with either unicast or multicast. This is for the underlay. So for example, even for the individual mode, you may be able to use multicast transmission to send from MB-UPF to multiple UPF. Okay, so yeah, next one. Placed here is just a description of the 5G MBS. Sorry, next one. Yeah,
Okay.
so here there are some challenges. So the first one is like for the 5G MBS, because the new control plane and the user plane functions, network functions introduced, so it's going to pose some additional provisioning and implementing challenges. So you try to relay and stitching between UPF and UPF and the DN here. Uh, Other challenges as the third one, well, like the second one is like a three new interfaces. It's corresponding to three different segments. And then those three, as I have already described, the three segments can use either the unicast underlay or multicast underlay. This will make the implementation more diversified, but also means a little bit more complicated or challenge. So next one. So next slide. Yeah, sorry about that. Yeah, here I use the requirement from RFC 733 is a requirement for DMM, distributed mobility management. It say, okay, multicast efficiency between non-optimal and optimal routes. Can you click? Uh, can you, uh, no, actually it's animation. So why oh yeah, okay. So here this is like, because the 23.247 require all downlink multicast traffic goes through the centralized MBUPF regardless of individual or shared. So it's kind of less efficient if the operator's 5GS is deployed in a location that is relatively distant from the customer edge site. So actually, well, it's already, I would say it's kind of the common in operators network right now for the 5GS, and then in the network in the field deployment in some operators, the UPF actually is already distributed close to the edge site. That's why it's here I emphasize the 5GD UPF. So with this in consideration, I can go to the next one. Next slide. Yeah. So as or you can just click through and then to show the full contents of this slide. Well, one more. Yeah. Okay. So here is like the proposal and the considerations, like how to use the DUPF for 5G MBS. The DUPF case, and then we're going to deploy the UPF close to access network, basically the GNOB. So in that case, for the shared delivery, so if you still memorize the architecture, the brief architecture I showed, so the MB-UPF is like the centralized UPF, and then it goes through the N3MB, and then distribute and then the send traffic or transport traffic toward the GNOB. So here, if the MB-UPF or just like a distributed UPF is deployed close to GNOB, and then it's going going to be made much simpler, just like what Jeff has described in his in the proposal in the draft, to benefit from the DUPF deployment. For the individual delivery, here it involves two UPF. One is the regular, the other one is one MB UPF. So here, what I'm thinking or is like to distribute and deploy both UPF closer to G node B. So for this case, the N19 MB tunnel and the regular N3 tunnel, if you look at the architecture, so they'll be significantly simplified. So it's just like to benefit also from the distributed UPF architecture. And remember here, as I described, for all the three segments, for the N19 MB, N6 MB, and the N3 MB, those three segments, either unicast or multicast under transmission can be used. So here, if we deploy the UPF toward in a distributed mode closer to G node B, that will make the architecture or the transport architecture is much simpler. The other one, the third one, the long-term consideration is now is beyond the 23.247. So the thing here is it's like to integrate, so sort of similar, a little bit similar to the AN or G node B integration, the G node B and the UPF integration part. But here I'm thinking is like the regular UPF and BUPF together as a distributed UPF. So in that case, we'll make this one even more efficient, and also it's better for multi-cut traffic forwarding. It's confirming to the RFC 733 the request the requirement 8. But still, this is the long-term part since it's going to put the regular UPF and MB UPF together as a distributed UPF. So it's a long-term part. Can go to the next one. Yeah, can you click through? Yeah, I think there. Oh, okay. Probably that's okay. So here is for the next step. Since it's try to make the DUPF shared and in the video delivery mode, I try to refine more, and also in the AP domain, the contributing signaling for underlay transport, the VPN part. Since the SRv6 or this kind of things, how to do the signaling to consider further. And another part, actually, I'm thinking for the 3GPP right now, there's a project in SA2 about the UPES, the UPF exposure capability to 5G system. So in this project, there's some discussion regarding to use the trusted AF to influence UPF traffic. So actually, that one, when I was composing this draft, I'm thinking, okay, to use like a controller. The trust AF can be like a controller, such that for all the like the relay, the staging, and the control plane to integrate between the IP domain and the 5GS together. So I was at that moment, and also right now, and later, for the future to look at the trust AF things to see how it's going to influence the UPF things. So yeah, this is the next steps. Okay, so that is my talk. Comments, please.
Okay, thank you for your presentation. I think a few things. I think yeah, this is a new topic, interesting. I think one thing I clearly see that in the ID that you're not suggesting changing the 3GPP architecture, or right? I think I like the first statement, uh, but I think we want to understand exactly, yeah, what the changes will be, and what we can do here. But before that, yeah, let's see, if anybody has any comments and questions. Who is in the queue? One second. Any questions from the room? I see Hanu. Yeah, Hanu, please.
Okay, yes. As I already referred in my previous comment, uh, there is a reason why multicast UPF is centralized. It is because it's servicing multiple genome keys. And the reason why it needs to service multiple genome keys is that it's synchronizing PDCP sequence numbers to, to ensure that there are no duplicated PDU message packets. So there is a technical reason why it's upper in the hierarchy and not pushed at the edge.
Uh, Sorry, your voice a little broken, but
Yeah,
it's
TN,
fine.
that's true. You may have to speak up, Hanu. I think even I could not follow it, at least for some part. If you don't mind quickly repeating the question, please.
It was not a question.
Yeah, yeah, I understand the
It
comment.
was more of a comment that there is a
Yeah,
technical reason why multicast UPF is centralized, and the reason is that uh, the multicast UPF is servicing multiple G-node Ps in order to synchronize PDCP sequence numbers.
Um, yes, but the thing is like, I try to how about like say for MB UPF. So the thing is like when the 3GP is set up the control plane, and then there is some criterion to select the MB UPF. Yes, I agree with you. One MBUPF can be used to talk to multiple GNOBs. Here it's like, say, even if you put this one close to some distributed locations, you still can do the similar things, especially for the large deployment for some countries with large network, mobile or 5G networks. So to be honest, I am not seeing any discrepancy here. It's like, say, suppose you deploy the MBPF in the centralized or in the distributed locations. So it still can handle the multiple
right. So
GNOBs.
TNG, this is a great technical discussion. Let's, I think Hanu's feedback. Why don't you respond in the mailer? We take it
Okay,
from
sure.
there. Yeah,
Yeah,
no? I
sure.
think
Thank you.
we'll also ask, let's also ask others to review the document. And I think if there no, if there is interest, we can see what we can do. So
Okay, sure.
the next step is truly we want to see some discussions on the mailer. Yeah, Dean, I want to
I
make
just have a
sure.
general comment. We have about
Just
35
quick
more
one, yeah,
minutes in
please.
the meeting and one more
Yeah.
presentation. So if there is an interesting discussion, why not use this time right now in order to go through it?
No, we have to repeat at least one presentation, and we also have one more topic. Yeah. All right. Next, yeah. Thank you again, TNG, for your presentation. I think yeah, there is interest. Let's take to the mailer. Yeah.
Sure. Thank you.
Next one is, yeah. Next topic. Next is the satellite communication. This is again a new proposal. Satellite network problems and solutions from L3 perspective. I
Can you
was
hear
not
me?
sure exactly what we are proposing here, but let's hear from the authors.
Can you hear
And
me?
yes, please go ahead.
Okay.
It's all yours. Yeah.
Okay. Thank you. Uh, Hello everyone. My name is Ling Han, and my presentation has a couple of draft. First draft was the problem and the requirement for satellite network, which was published in IETF 111, and the second one is semantic address published in 112. And this IETF, we published two drafts related to the solution. And one is interactive routing, second one is OSPF monitor nodes. Because this topic is quite broad and we don't see any dedicated WG can hold it. So we try to present in different working group to seek more comments. And so far only OSPF, we know we have to go to ASR, but for other things, we still don't know where we have the best WG. We will seek the comments from different communities. Second slide, please. So what is the objective for our work? Our work is for the to explore the open solution, specifically layer 3 layer for large-scale LU constellation. LU is a low Earth orbit. And any problem? Okay, so the constellation is used for the internet access and NTN integration with 5G and beyond. And first, this kind of network has a huge number of nodes. For example, just like the Starlink, more than 10,000 satellites and more than million ground stations. Second is that we assume the intersatellite link is used. Right now, for example, the Starlink first beta service only uses relay technology which doesn't have ISL link. But right now they start to experiment it. With ISL, the satellites will be connected together and form a network. And the third objective is that the satellite network has to provide global coverage. It's just like a very local or very small distance. And also we try to explore solution which can be used for the regenerative modes proposed by 3GPP. In this mode means that every satellite is kind of play multiple functions from GNOB to the network node. And for that kind of requirements, IP is the infrastructure. For the NTN integration, it will play like the transport network for the current 5G or 4G network. So what do? We will do the basic IP technology for satellite network. And so far the draft are only informational or experimental. We want to seek the feedback from WG. And obviously this topic is quite complicated. So far we only have a 3 draft about solution. Definitely is not enough. I think maybe more will come. What we will not do? We will not do anything regarding the 3GPP. It's okay. And first about problem, that's the first draft we had. And the draft may not be quite long. So if you want to see more explanation by slides, we have a workshop which was done to the University of Surrey. And the slides answered most of questions collected in IETF and other discussions. And most of the questions are not really about the technical, it's about why we do this kind of work. And secondly, that we have a little bit detailed introduction about what 3GPP NG-RAN published for the requirement for satellite network. They have a very detailed description, and for those requirements, IP definitely is kind of a requirement. Infrastructure has to provide IP connectivity. Also, we provide some simulations for mobility, links, and paths. From those simulations, you can see how challenging of this problem. Next slide, please. And this is about a second draft, semantic satellite address. And for this IETF, we have some updates, add a co-author, and also add the 32-bit semantic address at this section. And because people may not be aware of this, so I have a simple introduction here. Satellite network is kind of where all its moving objects. So it has multiple layers. Layer is kind of depends on the altitude of satellites. And each layer is an interleaved grid network, which means 50% satellites moving in one direction, another 50% of satellites moving in another direction. And by this organized network, we can easily think about to identify the network by different index. Right now, we introduce three index. One is the shear index, which will tell which layer of the satellite belong to. Second is the orbit plane index, which will tell which orbit it will belong to. Third one is a satellite index. It's tell which satellite in the orbit. For example, this one, the first index is 0, means the shear index is 0, means that all altitude belong to 0 shears. Second one is 10, is orbit, means that this orbit belong to index of 10 of the orbit. And the last index is represents which satellite in the orbit. Next slide, please. So this is about the latest draft, which we propose the routing solution for satellites. And why we need to think about new solutions? Because of the current distributed routing algorithm, IGP or BGP will face a lot of challenges. And we have constant satellite to ground station link flipping and very frequent. Also, the constant link matrix changing because of the link distances changing. And also the constant unstable link flipping. Unstable link was defined in the problem statement draft, which is the links between adjacent satellite moving to different directions. And also possible link interruption at the polar area, which links are the links between adjacent satellites moving to the same direction, because those satellites will cross over at the polar area. So the links may also be interrupted. And all about will cause a huge IPP protocol message flooding and reduce the service time dramatically. Next slide, please. Next slide.
You can forward your slide or yourself.
Hello?
You know how to forward?
Doesn't work?
Or maybe...
Next slide.
So there is some. Yeah. You lost the sharing. Yeah. One second. Yep.
No, earlier. Again. Okay. Next slide, please. Okay. So this is a review how the satellite network is moving topology looks like. We have a satellites moving at very high speed, and 50% moving to north to south, and 50% moving from south to north. And the link matrix between the ISL is keep changing because the distances keep changing. And also ground station to satellite link will be frequently changing. And also the link matrix will be changing. Besides the satellite moving, the ground station is also moving with the Earth's rotation. So that's why the topology is everything is moving in this topology. Next slide, please. So what is the problem when we use IGP for satellite network? Because of link number is huge, and for example, Starlink, we have over 1 million ground station to satellite link. And every satellite ground station to satellite link will be flipping in about 5 to 10 minutes, depends on altitude. If we use a traditional IGP, this will cause huge number of LSA flooding to whole network. So there's a simple math which can roughly estimate that every second we will have more than 3,000 times link flipping. Definitely, this will dramatically reduce the service time. Here we have the service time definition is remove the reconvergence time, then the remainder time will be service time. It's estimated that less than 20% for a network. Next slide, please. So what is the best solution for satellite network for IP connectivity? Definitely, we have to think about what is the spatial characteristics for the satellite network. And the satellite network is a carrier network for internet access and MTN integration. Means that.
So if I may comment, all right, you may want
Sure.
to relate, how this work would be relevant in DMM to DMM working group. If we can.
Okay. So actually, in
So,
my
another 5 minutes if we can wrap it up, because
Sure.
I want to make sure John has his time. Yeah.
Okay, so basically, when I present in other groups, people think the DMM will may be more adaptive, and some people even ask me why DMM cannot be used for field. So that's why I come here to seek more comments. Yeah. So I quickly go through. Then the satellite network is a transport network, and also the constellation is well ordered, even it is extremely dynamic. It's a multiplayer and a grid network, even interleaved. And limited number of ISL. And also the address, as I said, can be self-explained. Third point is that satellite position is predictable with the time, because we know the orbital elements. So all satellite adjacency and the link matrix can be estimated. Next slide, please. So we have think about some solution principles. First is that we have to maximize the usage of computation, because I said the satellite position is predictable. So we don't need to use a protocol to dynamically populate those informations, such as the network topology, link matrix, and the ground station to satellite link. So we can borrow we can borrow a current IGP for satellite network topology and state detection. For example, we have this draft which will isolate the extremely unstable link. And also probably more draft will come out for the parse. And we will utilize the special characteristics for satellite, for example, the address part. And also we want to minimize the routing overhead, because right now with all those information, routing is a still challenge, because as I said, the regular routing, the flooding issue. If we use soft routing, then segment routing, the overhead is too big. So for this new draft, we propose a new interactive routing, and we use instruction list instead of segments. And the segment address use a semantic address to compress the instruction. Thus, there will be much less overhead. Next slide, please. So this is how interactive routing works. It's very simple. For example, if we know the path from here to here, then cross some satellites, then we can easily convert the path to be whole path to be some segments. Then from the segments we can convert to be instruction list. The instruction list is composed of the function and arguments. The function is that will tell forwarding to which direction and until which satellite. For example, this incremental satellite ID means that the incremental direction until reach a satellite ID equal to hex 17. And the second instruction is that forward to incremental direction of the orbital plane index until the orbital plane equal to C. And third one is incremental direction forwarding to of satellite ID and until satellite ID equal to 4. Last one is end the forwarding and send the packet to the ground station by the interface ID. Next slide, please. Yeah, this is how the user plan looks like if we use the tunnelless mode, which means the instruction can be directly embedded into the some extension. Right now, we propose to use the routing header, and then the packet will be formed at a ground station, then sent to another ground station. And for 3GPP point of view, then of course we can insert the GPU tunnel here. Then everything is the same. Just the forwarding mechanism is different because we don't even need to look at the source and destination address in the packet header. Next slide, please. So a summary of the instructive routing, it fit into the special requirements of satellite network and reduce the distributed protocol message, which is a big overhead for the solution. And it will eliminate the population of huge number of internet prefix and segment routing SID. And also, we can see for the forwarding, it's simpler because it's a satellite, it's not like a regular router. So we can reduce the TCAM usage because the TCAM is still expensive in satellite because satellite environment is different. And by effective routing, it will has much less packet size overhead. And for example, overhead will be number of segments plus 1 times 2 octets normally. And for regular satellite network, if ISL is not broken, then very limited number of segments. Last is that we can reduce the ISL link bandwidth consumption for control purpose because ISL link is still very expensive, maximum about 10 gig so far. So reduce the link consumption is still very valuable to customer. That's it.
Thank you, Lynn. I'm not going to take any questions at this time, but I think, Lynn, if you think DM working group can help on, if you need
Yeah, I
anything
just
from
want to
us,
seek some comments from the DMM because people ask me to come ask the DMM if the DMM can solve the problem. If not cannot solve, then this definitely is a work we can do. Yeah.
yeah, let's discuss on the mailer. Let's see,
Sure.
how it relates to mobility and what we can do
Sure.
here, and if it's in the
Yeah.
charter. So with that, thank you so much, Lynn. And next topic is John. Can we go back to your quickly an update? Yeah.
Thanks.
Yeah. Again, this is an update on the working group document. John, this time we can hear you. Please go ahead.
Okay, great. Okay, next slide, please. So the changes in this, I'll try to be as brief as possible in the interest of time. Thanks for giving me this opportunity to present again. So the new draft, I mean, updates from version 2 to 3 is that the comment that the draft text is not focused is being addressed, and also changes to reference the drafts on slices, for example, in T's, and then a few other miscellaneous changes. So if I could go to the next slide, please. So the changes to focus this draft is mostly in the introduction, but there are a few miscellaneous changes also. So the key changes, I'm just putting a few snippets here to give you a look into what has been done. Um, Basically, the slice aspects as it relates to 3GPP is highlighted here. So basically that the slice in 3GPP is a logical chunk of 3GPP resources. And then in bulletized form, we add, why we need or what is being done in this draft. The fact that 3GPP standards do not address the IP transport network capabilities for slices and so on. You can read through those items. And also, what we do in terms of the network interfaces and the slicing in the transport network and how it is mapped. So those changes are made very crisp, and we remove all the other text that is related to routing and everything else. So it's very focused on slicing 3GPP and what is being done to facilitate that in the transport network. So that's the major change. If you go to the next slide. Okay, the actions that are remaining that came up in previously were to share this with other working groups. That's something we've got to do. And then I think we would like to get more detailed reviews within this working group. And I think at that point, we should be ready to move forward
Okay.
and address everything else. I
Thank,
think that's all.
sorry. Yeah. Yeah. Thank you, John, for your presentation. So, from the author's point of view, you think the document is in a good shape? Ignoring the review part from the text point of view and from all the open issues that have come up so far. But of course, I've not seen many discussions. But at least from your point of view, this is on track.
Yes, I think we've addressed everything that's been coming up and has come up and focused
Okay.
it also. Yeah.
Okay, so but we want some reviews, some serious reviews, John. I think that is the problem, right? I think the next steps probably we should focus on that.
Thanks.
Yeah,
Yes, I
thanks,
agree.
thanks. Yeah, thanks again. And one second, was there any other? Just yeah, I think we can probably ask Murakami-san to present it again. Murakami-san, earlier you did the presentation, but nobody in the room was able to hear. Can we try this time? Let's see if it works out.
Okay. Can you hear me?
We can hear you. I want the room, somebody in the room to confirm whether Murakami-san is coming out okay now. Yes? Okay. Thank you.
Okay, thank you. So, I will make a brief update about the mobile user frame message encoding. So, please go to the next slide. So here is the change from the 00 version to 01 version. So we define argmov app message to carry the sequence number for GTPU message, and also added sheet flavor consideration sections. Next please. This is a change from 01 to 02 versions. So instead of the IETF draft, we default RFC 8754. Next please. So this is a change from 02 and 03 version. We added security consideration sections. Please next. Yeah, so this is a change from the 03 to 04 and 04 to 05 latest version. So we just fix the some title in the graph. So as a next step, we are thinking that the document has been already very stable. So we would like to make the WG adaptation call. Yeah. Three,
Okay.
Satori-san.
Yeah, thank you, Murakami-san. Any questions from anybody in the room? Any questions from the remote participants? Questions, comments? All right, thank you, Murakami-san. I think what are the next steps? I think adoption. I think we need. I think let's poll. Let's take this to the mailer and see what the folks. Just want some more discussions, and we can absolutely initiate a working group adoption call in the next before the next idea. Yeah, but if you can, if authors can trigger some discussions and make sure everybody, some people read this document, I think that will be great.
Okay.
Thank you so much. And with that, this was the last presentation. And Eric Klein, anything you want to comment before we wrap up the meeting?
Just thank you to everyone for bearing with the the issues with the hybrid meeting style. I appreciate everyone's patience. Thank you.
Yeah. Yeah, thanks everybody, and also thanks for the folks in the room. You helped us. That's appreciated. With this, we wrap up the DMM working group meeting for IETF 113. Hopefully, we all meet in 114 in San Francisco. With that, thank you so much. And thank you, Satoru-san, Eric, and everybody, all the presenters. Thank you. Cheers. And
Thank you.
now I'll go back to my sleep. Thank you.